Hey guys, look at the time, it's Sunday. Well, you know what that means. Since I told you that it was kind of rainy yesterday and stormy, I couldn't go to the flea market, but I did the other video, which I think some of you might have seen. Um, but the flea market is open every Thursday, Saturday, and Sunday. And Thursday, I never went there Thursday. I usually go there Saturday, and I was disappointed to see that my regular drug dealers weren't there today. But I did find a few things. Actually, I did quite a haul today. Not a lot of interesting, not a lot of exquisite things, but I'm pretty sure there's a few things here that very few people have ever seen inside. So let's start in the, like usually, in ascending order of interestingness. Oh, by the way, I have I need for my Doom playing oscilloscope. I needed a Windows XP compatible machine to transfer data from one to the other via the network. So I hooked them up to a switch and blocked them from the greater internet, and that's how I loaded the Doom. Basically, I loaded Doom onto the scope. So that machine crapped out, and I managed to find the new XP machine. It's an old, I think it's a compact, HP compact thing, with a Pentium 4 and a 40 gig hard drive. And I scored it for about $10. So fully working. There was even some, let's call it mature adult content on the desktop even. So, and a signed in user on Yahoo Messenger. So if you ever ditch an old computer, make sure to wipe that thing. You never know where it's going to end up. I'm going to wipe the hard drive and reinstall Windows on it just in case. So, first thing I found was this. It's a Motorola, I think it's a 9700, something like that. And I got it because of cheap, of course, and in the interest of brevity and getting through these a bit quicker than my usual pace. I have already taken the liberty of taking it back off, so you can see the circuitry. So this thing didn't have a battery, and it's a clamshell that so it's the microphone is covered when you're covering this, and the keypad is also covered to like stop you from dialing people, because dialing people was very expensive back in the day. And this worked on 900 megahertz or 1800 megahertz. So let's try and take it out a bit more than I've already disassembled it, and see what's inside. If I make a mess of this thing, please don't judge me. Like, I don't have any interest of, using this thing, of course, right? Like, okay, so first of all, there's a connector here for something, and we can see that there's actually two boards sandwiched together. So this must be the RF board, basically, because there's the antenna connection, and a Lucent chip. I've never heard of those things. A Natmel. This is probably a memory of some description. A Sony. An AMD. Look at this. So AMD made other things than Ryzen. I'm not sure you're gonna be able to read that text over there, but it's an AM29LV 8008. So, God, if I know, I have no idea. Those of you who've watched one of the previous flea market finds might remember this tantalum capacitor. So the RF in these things was actually pretty powerful. So we're going to take these caps off, these shields off, and we're going to take a closer look here. But I remember that older cell phones had very good reception everywhere, so they must have packed some really quite powerful amplifiers for the antenna. So yeah, and behind here we have the SIM card locator. This thing, I didn't know what this was, but I'm assuming, now that I look at it, I'm assuming it had a plug-in thing, like a plastic cradle, which held the SIM in, and when you inserted it into this slot, it would contact on these pins. And behind here we have a the keypad, the main membrane keypad for the buttons, and oops. Ignored the use of percussive maintenance. I'm really not trying to preserve this in any way, shape, or form. I'm just trying to get it out so you can see what's behind here. Oh, also very interesting. This thing has no screws in whatsoever. So that's got to be the speaker, and I ruined it. I'm sorry. No, this is the speaker. This has got to be something like a microphone here. And the vibration motor, haptic, well, before haptic was haptic, and it looks very, very sturdy. Like, this is one of the beefiest ones I've ever seen. And yeah, basic membrane keypad. I don't think you can hear the clicking. These are they're very nice ways to make a very long-lasting sort of feedback-y keyboard. So there's a collapsible dome of metal that when you press, springy metal, and when you press, it shorts out 2 traces on a PCB, and then it buckles back up to its original shape pretty quickly. And there's a lot of, as you'd expect, a lot of Motorola parts, and this is a thing, this is a switch which detected if the SIM card along with its cradle was fully inserted. So give me a second to try and take out some of the shielding on these things. I hope I'm not gonna have to desolder them, but it looks like that. And we can take a look at what's going on underneath here. Mind you, I'm no RF expert. Oh, and also it had one of these extendy aerials, and there's probably a switch in the shape of these 2 contacts here or something. No, there's I get it. It might be a coupling sort of transformer. So there's some winding here, and there might be some sort of coupling from here to the antenna. I have no idea. Okay, give me a second. I'll take these off and I'll be back. Alright, so that was quite a bear. Well, we can see here that there's a lot of circuitry around here, and I'm not very good with RF. But I can make some educated guesses, and considering the fact that there's an antenna connection from here to here, so this is the antenna connection, this is some matching probably for the antenna, and you can see the signal splits kind of into 2 sides. I'm assuming this is the transmitter part, which is the power amplifier and something along those lines, and this must be the receiver because it looks like there's a couple of filters, and these are very interesting RF components. I've never actually seen anything like that. So they're using some precisely dimensioned cavities in this stuff that looks like ceramic in order to get, I'm assuming, very good performance filters. And you can understand why cell phones used to be extremely expensive. So this is a lot of RF gear for a consumer product. And you can see how I took off those shields basically, and I sacrificed some passives around here. I heated them up with a soldering iron, and I added some solder in order to transfer the heat more efficiently, and they lifted off pretty easily. Here's a very nice, I don't know if you can see it in this right here. You can see that's an inductor, I think. It's a coil of something on a substrate, and see these cavities and these components here. I'm assuming these are filters of some description. Yeah, that's about everything I can tell you about this device. Yeah, I'm not very good with RF, but oh, and also this thing used to work on 2 bands, so it might have something to do with that. So anyway, I'm out of my depth here. So let's go to something that's more along my lines, and let's look at a utility power meter. Basically, this is an energy meter. This is one of those 2-winding, basically eddy current sort of power meters. It measures. I'm pretty sure it only measures active power, so real power, in watts, in kilowatts hour, basically. And it uses something very interesting. It uses a trick. It has 2 coils inside. I'm going to show you what's inside in just a second. By the way, I have a fascination for Casio watches, like this one. I love the G-Shock series, and I don't know, I always find vintage looking Casios fascinating. So let's take a closer look, and I'm gonna get these things out from here as well. So this is the kind of electricity meter that everybody in this country had for a long time now. So these were very, very common, and they still are. I think my energy meter is still kind of like this one. They're starting to switch to smart meters and you know, going up to being in line with the times, but these are still very common because they're very robust and reliable. Okay, so what do we have here? We have a winding here, which is made out of a lot of turns of very thin wire. And we have another winding here, which is a lower number of very thick turns. So you would mount this in the following configuration. You would mount this winding in parallel with the input to your house. So this winding measures the voltage coming into your house. And then you take the live and run it through here, and then from the output of this coil you'd run it to the rest of your house, and return the cold wire would come back out to the distribution panel. And what happens is that these 2 coils acting together on this aluminum disc here will produce a torque proportional to the basically proportional to the amount of energy that you use. So the more current at the same voltage, the more torque, because the magnetic field generated by the current winding, the current coil, will be greater. So this basically runs at a speed which is dependent on the power you use, and it actually basically does mechanical integration of some sorts in order to calculate the total amount of electrical energy you've used. And you can see there's some fine-tuning things here, so I'm assuming this is sort of a shunt to tweak the probably something along the lines of a resistance of somewhere. So this is a very small resistance that you can tweak, and there's another gap that it can tweak in order to affect the accuracy basically of these things. I'm not sure if they're very accurate, but they're not really, it's not really crucial for these things to be very accurate. I'm not sure if I explained it very well, and I'm not really 100% convinced that I can still remember how to prove how these things work. So I'll try and link a video about how these things work. But anyway, you can see 2 thick terminals here. So beefy wire. I'm not sure if it's going to focus. Yeah. and two thinner ones, which are the voltage coil. I might do a short video about me wiring this up and pulling a load through it and seeing if it actually still works. Most likely it still works, and yeah, this one had 20,395.4 kilowatt hours, so it had quite a lot. I think 20,000 might be 200,000. Let's see, 20,395.4 kilowatt hours. Yeah. Oh, and the way the newer ones work is just they have a current transformer going basically towards your house on the live wire, and they have a voltage measurement device, like either a voltage transformer, basically a measurement transformer, or a resistive divider or something. And they have two true RMS converters, so they have the voltage and the power and the current. They convert that to true RMS, and they multiply them, and they get the power. They integrate that power over time, and you get energy use. Actually, you just multiply power times time, and you get energy. So yeah, this is an old electric utility meter, and it's made in Poland of all places. I'm not even going to try, and I just had a faintest thought of trying to pronounce this thing here, but no. Made in Poland, Bafal. Svitnica? Something like that. Anyway, so this is how Romania still measures its electrical bills. Basically, Romanians still measure their electrical bills, and I hope they're going to switch to something that doesn't make me go out to the hallway and read the darn thing, because it's kind of nasty. Like, it's not great. Just have something with low power wireless or something like that, and let the customer just pay for the stuff. Don't make them do more work than they have to. Okay, second item on the list. Let's move on. I don't know if you can tell, but I'm trying to move faster and it's still not working. Okay, so any ideas what this might be? Well, this is Romania's national coin, the leu, Plion, basically. I don't know where it comes from. And this is a banknote acceptor. It's like one of those things you have on a vending machine that takes banknotes. I think it actually comes from a slot machine, because Romania has a massive problem with addiction to gambling. There's a lot of people in Romania who are addicted to gambling to the extent that it's become sort of a foul meme. This happens in poorer countries because gambling is seen as a way to escape poverty by the lower classes, and this is they're taken advantage of because it's basically an illness. So gambling works on the same principle as any other kind of addiction, and it's been proven that if you're a person who's easily subjected to addiction, you should stay away from gambling because it's going to ruin your life. So I'm assuming this comes from a slot machine of some description. So there's some gears here, and how this thing works usually is that all banknotes have some distinguishing features which are printed in UV ink. So a £5 note will have a 5 written somewhere, a €5 note will have a 5 written somewhere, and they also have those safety features. This is a Romanian 10 lei banknote, and I'm not sure if this is young enough to know to accept it, but you can see it here, so it's the same. If you put this under UV, you're going to see some 10, marking 10 somewhere. I don't have any UV LEDs because I would have shown you. And there's the filigree safety line, and there's another few things to ensure this is a real banknote. So we also have plastic money, and we've had plastic money for quite a long time now. It's far better than, you know, uh, like American dollars, or I think the Brits have started, you know, introducing plastic notes as well. But anyway, let me try and take this apart a bit further, and we'll try and see what exactly is inside here that makes it tick. Oh, by the way, that note you saw is the equivalent of basically right on €2. Alright, so apparently there was some moisture in this because probably the guy was caught in the rain. I don't know. Anyway, so this is the backside of the machine. This is where the banknotes would have been deposited in that receptacle. And this is the flashy green insert your money here port. And there were two, I'm assuming they're pretty bright green LEDs shining through to the outside. I don't remember exactly on which board I've seen them. But anyway, what happens is that there were two boards stacked over each other, these two. And we can see there's a few LEDs in here, and there's some optical sensors here. I think those two are actually CCDs, and they're waiting for the things that I told you. So the coin was brought towards this thing, which, if needed, I think they could have flipped the coin. The note was brought in through here. There's a couple of timing belts which helped it be carried flatter on the surface, and they could flip it around if it couldn't find any of the UV ink, basically. And if it accepted it, this thing would just pop open one way or another and release the note into the acceptor. Otherwise, it would just spit it back at you. So I'm gonna try and take it a bit further apart to see what's on this board, and I'm gonna try and remove this board as well and see if there's any interesting LEDs we can snag out of here. Alright, so apparently I had been talking out my ass a bit. These were the two LEDs that were flashing through these windows here. And apparently there's a couple of red LEDs, a couple of, I don't know what these are, might be infrared detectors or infrared transmitter or something like that. So I'm assuming that the safety features like the infrared, the UV ink is in completely different places on all banknotes and of different shapes and sizes. So they're probably just doing that. I'm not sure this device could be adapted to many different currencies, but I might also be wrong regarding that as well. So we have a motor driver here, some sort of glue logic, an NEC microcontroller, and that's about it. Made by International Currency Technologies Corporation in 2007. Right, so if this thing was in a vending machine, fine, but the currency that it accepts makes me think that, so 500 lei is around 100 euros. So I'm assuming this came off of a slot machine, and please don't gamble. No matter how much money you're gonna win, the bank is always gonna be the owner of the slot machine or the casino is always gonna win more than you. And the flashing lights and the beeps and bops and sounds that these things make is specially tailored to trigger that happiness response in your brain. So it's one of the sleaziest things that has ever appeared on the surface of the earth. Gambling, especially slot machines, they're so perfectly tuned to extract every last drop of money that you have that it's despicable. It's completely disgusting, and I despise everybody who is in that business. And hate me all you want, but you're stealing people's money. You're not into games or anything. Screw you. If you claim that you make game machines, go to hell. You're stealing people's money away. And you're taking advantage of sick people, just like those guys who are making commercials for alcohol and cigarettes. You're using somebody's addiction against themselves to make yourself richer. So please go and, you know, I'm not gonna say it, but you understand what I mean. Right. I have one more item, which is not very interesting, but it allows me to do what I like the most, and which is go on tangents. So, no. An N961 made in GDR, so the German Democratic Republic. Web Mikrofontechnik Gefell RFT. RFT, I think, is basically like these main electronics components thing that was in Eastern Germany. So, you know, after the Second World War, Germany split in half basically, and the East was allied with the communists and the West was allied with the Westerners, and the Berlin Wall appeared and all the pain and suffering until it finally came down in around 1989, right? What I find fascinating is that the Berlin Wall not only represented the split down Germany and down Europe basically, but it also represented a massive gap in technology. So the East had, as I've shown previously in a number of different videos, the East was left trailing behind everybody else. Their technology was so much worse. They had such of a hard time catching up that most of the Eastern European countries are still struggling to this day, Romania included. So this is not necessarily a demonstration of that particular thing, but it's still interesting to think that there were two Germanys with two vastly different lifestyles and basically, you know, living standards. And I think the Germans who who were there to find that, only tasted a very slight, like a trailer for what it was actually like in the further you separated away from the Berlin Wall. What is this? Because I went on a tangent again, I'm sorry. What is this? This is something I picked up for a couple of bucks at the flea market. It's got a very nice thick steel enclosure, and we can see that it's a stereo microphone pre-amplifier, I think. I think this means output. Ausgang. Microphone, it's the same thing as in Romanian. This is a fuse, I think, or something like that. Yeah, it's a fuse, a 25 milliamp fuse, so it's not using very much power, whatever this thing might be. And these, I think, are DIN sockets or something like, I'm not sure if they're DIN, it might be different. Anyway, they're audio style sockets. So let me just take this apart, if I can find a proper size screwdriver. By the way, I really like these WIA Pico finish screwdrivers. I actually have quite a fair number of sets of screwdrivers, and when it comes to delicate work, I always reach for these. And I have another set of wooden handled WIAs, specifically for sort of like more mechanically things. Like this has a hex here, so you can crank on it quite a bit more, and I would never use something like this to open a mechanical enclosure unless I had been inside it before, which is the case for this one. So I didn't tighten the screws all the way down, so you can see that it only takes a bit of finger pressure to open this up. And it's going to pop open something like this, right? And we can see a pretty nicely made device. So there's a power supply section here. So we have a shield running down the middle, a nice grommet. Only 2 wires, so I'm assuming if there's a plus and minus power supply here, it's going to be derived from something like split phase single diode rectifier thingy. The input sockets looks a lot like an IEC, but isn't an IEC. I think this is a typical West German thing, but in traditional German fashion, even West Germany made things very cleanly. So you can see nicely routed everything wire here, and everything shaped properly and soldered and blah blah blah. So Germans had always very good work ethic. That's at least what they were telling us here in Romania. Let me go on another tangent. So you know Zeiss, Carl Zeiss, the famous optics manufacturer and microelectronics and stuff like that. Well, it started in Jena, and they've been making lenses and microscopes and optics and electron microscopes and telescopes and the lenses for ASML's UV lithography systems and everything like that ever since. So they're practically one of the best, if not the best, optics manufacturer in the world. There's a ridiculous thing in Romanian that when you want to say that something is made very well, you call it Zeiss. And it's spelled differently. It's not Z-E-I-S-S. I'm going to show you what it's spelled like in the description. And you can understand just how impressed the Romanians were about German quality things, that brand name became synonymous with excellence. All right, so what do we have here? Well, we have a couple of transistors, actually 1, 2, 3, 4. Tesla capacitors. Frolit capacitor here. Frolit. Couple of diodes, a bridge rectifier. This is got to be a Zener diode with the pigtail voltnut grade. It's mounted like this to help release the stresses and to dampen any vibration that this thing might encounter. Okay, so I'm assuming, considering the number of parts we're seeing and the fact that I've never seen any of the numbers, the part numbers on these transistors, I'm assuming these are a couple of like maybe JFET amplifiers or something like that. So you can see there's a grounding thing here, left and right, coming from the outlets, and these are passing straight through. I'm wondering if that might be something like bias or something like that. I have no idea. So 500 microfarad, 25 volts, 100 microfarad, 15 volts. Tesla actually made very good components. This Tesla, not the other Tesla. I'm not gonna go there. So let me just look up these part numbers, and it's an SF122C. Hold on just a second. So apparently this is like the bog standardiest above bog standard NPN transistor. Its HFE is 35, which is very low. They're not even high gain transistors. I'm not entirely sure what even is this thing. And I can't read whatever that thing is there. So it's probably just a couple of Class A transistor amplifiers, like a single transistor amplifiers, common emitter or something like that. I'm not entirely sure. Zener is probably there to set the bias through them. I'm not entirely sure about that either. would look a bit like a differential, but not into. No, it can't be a differential because it's a stereo. It's definitely two microphones and yeah. So this was made in I don't know if there's any date codes on these things. 1971, I think. So in the 70s, well, in the 70s, the rest of the world had progressed quite a bit from transistors with a gain of just 35. But as I said again, even the GDR had very good technology compared to the rest of the communist world. They were being bled dry by, it's at least my impression that there was a massive brain drain and they were working far below their parameters, but their work ethic was still there, and they managed to do pretty well for themselves. And this is why they still went back to forming one Germany, because you can't separate the nation in half and claim to be claim to have split into two countries. And yeah, people do very stupid things when they're greedy, and we're becoming increasingly greedy. I didn't put in the right screws. Anyway, so microphone preamplifier, probably something for I don't know, PA system or something like that. I like the box. The box is really quite nice. Too bad that these connectors are kind of chunky, because I could have put something in here, something else. And this looks like it would fit a IEC socket very nicely. Oh, actually, these are separated from the mains earth, of course. So audio, the ground for the signal isn't the same as the chassis ground. Yeah, these could be, conceivably, I could replace these inserts here with something else and add some, whatever, change the electronics inside to whatever I need. So it's a very nice project box, at least. Anyway, the last thing I found, and I'm gonna put this aside for a bit until I can show it to you. The last thing I found was another one of these beautiful vintage, with a bit gross, vintage VFD calculators. So I'm going to do something not very recommended. I'm going to mix and match some batteries, because I don't have three AAA batteries in the house. And I'm going to try and show you the display, because it's really pretty. Alright, so finally got it. I had to hook up an external power supply, and it's still kind of iffy, but you can see just how pretty the displays are. It's gorgeous. Want me to take it apart? I mean, of course you do, don't you? I'm surprised at how weirdly idiosyncratic some people's stupidity is. So these guys had these wonderful bits of, at least they're wonderful to me, wonderful bits of technology somewhere, and they were treating them with such disrespect. So these things were sitting out in the rain, and they were getting wet, and I don't know why you would ever do something like that. I'm going to stop and not show you how I try not to destroy this thing, and be right back. Alright, so I managed to extract the thing, and you can recognize some manufacturers which are still around. So TDK, Nippon, and this, I think that's an Elna or something like that, and a resistor network here, a ZA0552, and a beautiful VFD display. So this piece right here, this module right here, is the high voltage driver for the VFD. They run it around 30 volts or something like that, and the rest of the circuitry just does everything. So this chip is both the calculator and the display driver and the keyboard input and everything else. So let me just hook these up back, and let's see if we can power this on. And apparently it's not doing much. Oops, red wire goes to the positive usually. So I didn't manage to break it. Let me turn on the light so you can see what's going on here. So there's a couple of zeros now. 99999. And I'm touching some things behind it because it's kind of making it act a bit weird. Anyway, you know how these things were laid out in person? So they would have like a giant transparency sheet, and they would have a roll of tape, which was the thickness of the trace, and they would put their component footprints on the thing and then run the trace. And this is why they're so nice and pretty and roundy and organic looking, because they were drawn by organic beings, like humans. And even here you can see the same thing here. Holy crap, this thing might need some deoxit and some TLC before it gets like completely oxidized. So yeah, and when they started doing CAD for PCB design, like Protel and stuff like that, they could only use like either 45 degrees or 90-degree angles and stuff like that. They only worked with straight lines, so curves were very hard to do. And that's why the industry kind of completely ditched curved traces for a while. And there's that guy who did that very nice KiCad plugin that melts your PCB, and it makes it very nice, and it has teardrops and it curves the traces, and I don't know, to me it just looks a bit more human, more organic. Every time I see on basically an auto-routed or a PCB these days, it looks very much like there is intent, there is design intent, but there's no. And I know PCB layout is an art because I'm very bad at it, but still, but people would, I would appreciate to see a bit more like rounded PCBs for the good old times, because it just looks so much nicer. And yeah, okay, that is all I have for you today. I am going to try and clean this calculator up and make it pretty and try and save it from its inevitable demise into a gallon of rust. And I'll see you next weekend. Hopefully. Yeah, next weekend. So, as always, thank you for watching and have a great week. Bye-bye.